I wanted to take a couple of minutes to talk about the questions that we have specifically in our discussion forum this week, but they are also questions that you might just come across in the course generally, and they are questions that pertain to the concepts of future value and present value, which we reviewed earlier in the course. There happens to be a really nice worksheet that can help you to answer the questions that we have. So there's actually 4 different questions we're going to look at. And I created a Excel spreadsheet of this worksheet that's in your text. And it's basically using present value or future value tables, and then also an Excel function that is basically duplicating the work of a financial calculator to calculate future or present values of different scenarios. And what we're talking about here are generally questions that revolve around concepts such as, I would like to have a certain amount of money in a certain number of years, investing it at a certain interest rate. How much do I have to save each year, or how much do I have to have now? Those sorts of questions. So I'm going to just spend a couple of minutes here going over how I might approach these problems. So the problems that were actually in your text are what I'm going to leave in the worksheet for you to see as an example. The question is, how do we accumulate $330,000 in 18 years to meet educational needs for a child? So we know we're going to need $330,000, and we know that we're able to invest it at 6% is the rate of return or the interest rate. There's a couple of ways that we can do this. So in terms of trying to figure out, how much we would need to have saved now to meet this obligation, what we can do is we can take a look at the future value factor for a sum of money being saved at an interest rate of 6% over 18 years. So the way that I do that is I go into our future value tables, which are in Appendix A of our text. And I might take a look and say, okay, well, at a 6% rate of interest versus 5 or 7 or 8 or 9, right? In 18 years, I'm going to have a future value factor of 2.854. So that future value factor is actually going to be able to, what we're doing is we're taking the total sum of money that we want to have in 18 years, dividing it by the future value factor, and we're seeing how much we would have to saved now to meet this obligation in 18 years. We can use a financial calculator also to solve this problem by just plugging in, what is the present value, the amount we need now, given our future value, our time, which is 18 years, the interest rate. We're not making any payments. We're just saying, okay, we're putting this money in the bank and it's going to accumulate it's going to compound at a rate of interest of 6%. So the present value of that would be $115,000. And there's a little bit of a rounding error here that's due to this future value factor only having 3 decimal spaces. We can see that we're getting basically the same result. Why do we have a negative? So if you take a look at this formula, and if you're using a Mac or if you're using Windows, Excel has formulas too, and they're going to give you information about what to put in here. But essentially, the way cash flows are sort of regarded is that there are flows in and out. So we sort of think of like right now, we put the money into the savings account, it's an outflow, and then we're going to take it back out positive in 18 years, right? So at a given rate of interest for a certain amount of time, so this would be 6%, 18 years. We're not making any payments. This is not an annuity, although we could create an annuity here and see what we would need to have saved. The future value is what we would like to have saved. And based on, whether that interest begins compounding at the beginning or end, I just put a 0 or a 1. And right, so it's going to tell me exactly how to do this or what to input here. I hit enter. and I'm going to have that same result, right? But just kind of regard the positive and the negative as being the outflows and the inflows. It's just a directional metric. So then there's another question in your text that says, okay, well, let's consider the hypothetical situation that we want to accumulate $330,000 and we want to have that in an account in 18 years to meet the needs for a child. But we actually have $10,000 saved right now. And what we're trying to do is figure out, okay, we're not going to have 115. That's what we would need at a rate of 6% for 18 years to reach 330,000 in 18 years. What we're going to do is we're going to deposit money into a savings account at a rate of 6% in each of these 18 years, and we're going to see, what we need to deposit in order to have that money saved. So there's a couple ways to do it. The first way to do it would be to look at, what is the terminal value, so the future value of this $10,000 that we have saved. And what we can do to find that out is, again, we can use that future value factor, multiply it by the $10,000 that we have right now, and we know that that's going to be $28,540 in 18 years. So the remainder that we're going to need to have to save is going to be our future value of $330 minus the future value of the $10,000, which is $28,540. So I still need $301,460. So how am I going to come up with that? If I take a look at, instead of just the future value factor, I want to say I'm going to save money every year for 18 years. If I save it at a 6% rate of interest for 18 years, my future value of an annuity factor is 30.906. So that's my factor. And what I can do is I can divide the total future value balance, right? It's 330 minus our future value of the $10,000. I divide that by the future value annuity factor, and that means every year I need to deposit $9,754. So this is kind of helping us, going through the process this way is helping us answer the question. Assuming we have 10 and we want to make annual payments, we need to make a payment of $9,754. Given our $10,000 balance and the fact that we're going to be earning a rate of interest of 6% over 18 years, at the end we'll come up with our $330,000 that's needed. The second way of doing this annuity calculation would be to use a financial calculator or an Excel function. So what I did is I went in and I found the appropriate function, which is the payment function. And the payment function is going to tell me what is the payment that I need to make given, and then it's going to tell me all of the different inputs, right? So given a certain rate of interest, 6% over a time period, that time period is 18 years, the present value is $10,000 since we have $10,000 already saved, and the future value is $330,000, and we'll put a 0 for the compounding occurring at the end or the beginning of each period. And I just add all those or put all of those inputs into my formula. I selected at the end compounding, I hit enter, and I come up with the exact same result that we have. So we have to make $9,754 payments once a year for 18 years on top of our $10,000 original present value in the account payment, adding to it the $9,754, and in 18 years at a rate of 6%, we'll have $330,000 in the account. So that sort of helps walk you through how I would approach this in the text. If we take a look at, let's see, I'm going to pull up your discussion forum. So for example, the first discussion question, how much would Phoebe have to invest today in one lump sum to end up with $50,000 in 8 years. So that corresponds to our first question. So we want to have $50,000, and we instead, I'm basically changing this and saying I want to have $50,000 in 8 years for some reason. Here it's not for educational needs. I know that we're going to be able to invest that money at an interest rate of 10%. So I'm going to change the interest rate to 10%. And if I wanted to use the future value factor, what I would have to do is go and take a look at the future value factor for an amount of money in 8 years at 10%. So I would go into my appendices, I would go into the future value table factors. So at 10 years, let's see, interest rate is 10% in 8 years. So if the interest rate is 10% and 8 years, my future value is 2.144 here. So I'm going to put in 2.144. Okay, so $23,000 is what we'd have to have saved right now. Let's try it out with the financial calculator. Future value, 50,000 at an interest rate of 10% in 8 years. Looks like we need to have $23,325 saved. So I'm going to leave the rest of these here for you. I'll put the answers into your discussion form. Disregard this if you're not doing a discussion form and this is just educational future value, present value material for you. And I hope you can use this helpful spreadsheet to solve the rest of the problems now that we've gone through an example together. Thanks for staying tuned.